Um, Sharing our experiences, sharing our stories, storytelling is a big part of communication, a big part of how we learn together. And so um, I'm super excited to introduce Andy Barrett. Andy Barrett, who is who's going to be sharing his story of shifting to better science for future us. Andy Barrett is a dear colleague and friend. We've worked together for the last 5 years. He is at the U.S. National Snow and Ice Data Center, and he has been a Openscapes mentor with us for the last 5 years. So we've been learning together how to do science in the cloud and teach science in the cloud at the same time. And so his experiences are um, are super valuable, and I'm excited to listen along with all of you. Andy, over to you.
Thanks, Julie. Hi, everyone. Yeah, I'm gonna share my screen and take you through some slides. Okay. I think you should be able to all see my screen.
Yes.
So great. Okay. Yeah, as Julie says, I've been with Openscapes, or working with Openscapes as part of the NASA Openscapes program for the past 5 years. I'm based at the National Snow and Ice Data Center, the U.S. National Snow and Ice Data Center, which is at the University of Colorado in Boulder. But I actually live in northern New Mexico, not too far from Colorado, but just a bit to the south. Yeah. Well, let me just say a little bit. Most of you probably at ESA know a little bit about the NASA data center structure. There's 12 DACs, distributed active archive centers, focused on various disciplines. Obviously, the National Snow and Ice Data Center is focused on the cryosphere. Um, we also get some funding from NOAA to manage some of their data, focused again on the cryosphere. And we have a data center, and I'm part of the data use and education team there. But I am also part of the science team, so I do some research, and at the moment, my research is focused on using machine learning methods to map sea ice. Uh, and working on trying to use foundation models to do that as well. So I'm excited to hear a little bit about some of the work that you're all doing about that. So I started off as a field glaciologist. I originally come from Great Britain, and I was working on some glaciers in Switzerland, just above Zermatt. There's a picture here of me using a hot water drill to drill boreholes to the base of Findling Gletscher in this case, which is above Zermatt, so that we can instrument it with pressure sensors to measure water storage within the glacier during the melt season. Um, Most of that work was kind of spent kind of collecting data, analyzing data, downloading data from data loggers, but also transcribing manual measurements. We were measuring sediment concentration in the rivers, which involved using sampling equipment and filtering water, and we had data sheets and everything. So a lot of work kind of wrangling and managing data. And there was a clear need to organize and track data in a way that one, I could keep track of, but also so my colleagues could keep track of. This was a while ago, and I was in a geography department. There was no formal software training or anything. So we, most of us self-taught, group taught QBasic and a little C to do both the data wrangling, quality control, transformations, and also some modeling. So kind of things that we had to think about that I think about still is sensible file naming conventions. And I've put a link here to Jenny Bryan's talk on lightning talk on naming things. super important. Again, directory structure, kind of how do we structure this data so that it's simple, both efficiently computationally, but also so that a human can look at the directory structure and navigate their way through. And I think kind of these were things that kind of really kind of were instilled in me early on. And a lot of it was figuring it out as I went along, right? I was new. I just finished undergraduate and I was now working in graduate school, but having to do stuff that I'd never had to think about. So a lot of learning happening. At the end of that, I moved to NSIDC, National Standardized Data Center, and it was a complete shift, right? I was working on 14 square kilometer basins, and I moved to work on snow hydrology and hydrological modeling and Arctic hydroclimatology, and sea ice, but still very much a learning process. And these were kind of in the not the early days of remote sensing, but still I would describe it as a bit of a wild west where there were many data formats. We were focusing on metadata, but not actually using metadata well. And I had to learn new skills. Perl and IDL, which is I think the interactive or image data language or something, was a developed at CU, was free to us, and used quite widely within the remote sensing community. So I was learning that software as well as kind of learning working with remote sensing formats, and there were quite common kind of conversations that would take place over an afternoon, a day, even a couple of days. And it's like someone would send you a file and it'd be like, "What grid is this? Oh, it's the East grid. Well, which one? We have like 25. How many rows and columns does it have? Oh, wait, let me go check my code." And this was kind of just a normal practice, but it was quite frustrating when all you wanted to do was open a file. Should be pretty simple. And I was having to do what I call data forensics, kind of guessing at from a list of grids what the shape was, and then having to do some kind of calculations on the number of bytes to figure out what the data type was and things like that. And right, this would have all been solved by having metadata, having good documentation, but when it was being produced by colleagues, that wasn't necessarily there. It was just like, oh, here's a file. And it's especially difficult if you're having those conversations across time zones, because that just ends up they go home, they go for lunch, and you're still trying to work, and you're stuck. So reflecting on that, tools like GitHub or even Google Docs for asynchronous communication and documenting this information about files would have been fantastic, and properly curated metadata as well. And I put a note here: preserve discussions. Right, we want to keep track of all this information, and if it gets buried in an email, it gets lost. You have to go searching for it. So having some way to manage both metadata, but also your discussions about that data, I think are critical. And fortunately, tools like GitHub allow that. And these are kind of challenges and things that started me thinking along the lines of open science. So, another element, we had a project where we were evaluating sea ice projections from CMIP6, the Global Climate Model Intercomparison Project. And me and a colleague produced this paper, this figure here that I'm showing, which is showing historical and future projections of sea ice extent for the Arctic, for a couple of scenarios, and then comparing that with the observed. And one of the things that people I was working with wanted to do was to update this figure annually as the September sea ice minimum came along. And so every year there'd be like, oh, well, let's update the figure. That's a long time. A year, a week is a long time, a month is a long time, but a year is a long time to remember where was the script that I used to create this? What folder was it in? Which script updated the data, and things like that. So there was a need not only for me to kind of simplify it and automate the process, so that I could have one big script that would just update it, but also thinking about sharing the code via GitHub so that others could generate the figure. And having a way to search for that code pretty easily. And I think when I was talking with Steph about this earlier this week, she reminded me of Julie's paper here, Our Path to Better Science in Less Time, where she describes very similar challenges with trying to put together the Ocean Health Index. So I recommend going to read this paper. It's a really nice paper to read with your morning coffee, and kind of get another story about a path to open science. So that was kind of my beginning, and kind of being pushed to think about how I can improve my workflows. But I'm still learning. It is still a learning process, which is why I've called this evolution. But I think one of the things that has come about is realizing GitHub is not just a place to, it's not just a version control system. It's not a place to store code. It's a collaborative space. It's a way to capture discussions about code, about data. It's a place to manage your projects and keep track of issues, tasks, and things like that, that everybody working on that project, and you can open it up, can to not just your team, but to collaborators, to a broader area. So utilizing tools like GitHub for collaboration, I think, is really important. I think another thing that I started to do, even before Openscapes, joining Openscapes, was to use interactive computational notebooks. So I use Jupyter notebooks, but there are many computational notebooks like Google Colab, Mathematica, Azure notebooks. Um, and it's this thing that Julie just talked about of being able to combine code, output, and narrative within a single document, that allows you to document your workflow, document your decision making, document your thinking and reasoning about why you are writing a piece of code. And this is something that Donald Knuth talked about in literate programming. It's this way of trying to provide a narrative to the code that you're writing along with the code so that it's easier to understand. So yeah, computational notebooks I use a lot in what I'm doing. And again, part of Openscapes, I've been here as a part of Openscapes as a mentor, but as much as I've been a mentor, I've also learned a huge amount from all my colleagues and all the champions and the cohorts that have come through. It's just a great way of learning and finding new skills. And I will say Openscapes is my happy place. It's just a really good place to be as part of this. And as I say, I'm inspired by what other people are doing, experimenting with using Quarto and Jupyter notebooks to write executable papers, so that I don't have to cut and paste numbers into a table in a Word document. I can actually generate that table automatically and have it updated as I update data. Is a way forward. So a project that I've recently wrapped up is a rain on snow database for the Arctic. Rain on snow is a big issue. It impacts kind of just transport within the Arctic, but it also has an impact on reindeer herders because ice crusts form in the snow, and reindeer will generally burrow through the snow to get to lichens at the base of the snowpack, with that snow crust there, they can't feed, and this impacts caribou and musk oxen as well, and other ungulates. And we wanted to learn a bit about this, and learn about the frequency and things like that. And so we put together a database based on automatic weather station data. And I wanted to do this as openly as possible and also manage the code. There was a lot of quality control involved, a lot of processing, a lot of resampling of data. So using GitHub to recreate so that I could recreate the database, update the database with a few scripts was something that I wanted to do. So having that public so that my colleagues could do the same thing and help with it was important, and also document what the database is about was pretty critical there. And then making sure that the database was archived in a public repository. In this case, this was NSF funded work, so it was archived at the Arctic Data Center with a DOI. Included it here on the slide, but I think this really kind of formalized the way that I kind of tried to approach doing the scientific data science, and kind of incorporating things like testing of code and this literate programming idea of documenting the code well within notebooks as well as within scripts. So I'm not going to say that these are, I mean, these are kind of lessons learned, but these are things that I try to remember, try to incorporate into my everyday work, which is, and when I'm starting new projects, is to aim for reproducibility from the start. I mean, it's this thing of, and I think someone mentioned not perfect is adequate, right? You can always improve on your code. I'm a hack programmer. I self-taught. I have some bad practices, but that's okay because others can modify it. Others can update. Others can help me make that better. And really adopting this idea of forking and building on not just allowing other people to build on what I've done, but allowing myself to build on what I've done. And reaching out to the community when problems arise. Right, this cohort is one community, but there is even broader community out there within the larger Openscapes community, the larger scientific community, larger ESA community. I think just utilizing tools such as Slack or whatever communication tools you have access to, and asking questions, sharing knowledge, sharing just cool stuff that you found that has improved your work is very helpful. I would say document the stuff you think is important and also the stuff you don't think is important. I think I saw in the comments somebody said even the minutia. I think that's really important. The later you'll always discover that it was helpful. It's always important. And I would say something that one of my colleagues, Amy Steiker's, kind of introduced me to is the idea of documenting decisions as much as documenting how to do things. I'm a contributor to the Earth Access package, which allows you to access NASA data. And we've just moved that to a new repository and outside of NSIDC. So it's a kind of more of an open source, open science project, and documenting that decision process so that we can then explain to people and show this to people why we've done it, and reminding ourselves why we've done it has been really, really useful in getting that process to completion. So yeah, I mean that's my story. Those are some of the things that I think are important here. There's probably many others, but that was what I felt I would like to share with you. So I will finish there, and thank you for listening. And it's great to be part of this group.